Today, we are analyzing a million-dollar engineering marvel, shaped entirely inside a wind tunnel. The hidden details on the outer shell of the Ferrari Amalfi Spider will completely change the way you look at supercars. Ferrari uses an aerospace-grade paint technology on the Amalfi Spider. While a standard luxury car carries up to 20 kilograms of paint, this vehicle reduces that load to just 9 kilograms by shrinking the paint layer to a micron level. To achieve perfect smoothness and prevent air molecules from clinging to the body, expert craftsmen spend days hand-sanding the panel joints at the Maranello factory. The real engineering precision shows when you look closely at the exposed carbon fiber panels. The weave direction of the carbon fibers on the left and right fenders meets at the center line at a perfect 45-degree angle, forming a spine-like symmetry. If a single fiber is misaligned during production, that entire panel is scrapped. Finally, a specialized protective clear coat is applied, which pops the carbon texture under sunlight while remaining molecularly smooth to eliminate drag. The aerodynamic engineering of the Amalfi Spider splits the airflow into two highly calculated paths: upper body rooting and underbody ground effect. Air entering the front bumper finishes its cooling duty and flows over the smooth hood without hitting any obstacles. Engineers designed the upper surface as a single piece to prevent flow separation, allowing the air to clear the windshield and form a clean path toward the rear. Underneath the vehicle, we are met with a completely smooth and flat underbody architecture. Unlike traditional cars, no exhausts or mechanical components are left exposed to disrupt the airflow. This perfectly flat surface maximizes the speed of the air passing underneath. When this accelerated air reaches the massive rear diffuser, it creates a powerful low-pressure zone based on Bernoulli's principle. As a result, the car is literally vacuumed to the tarmac as it reaches higher speeds. The rear two-stage active spoiler adjusts its position within milliseconds, based on steering angles and g-forces, to lock the rear axle to the tarmac. The real masterpiece happens during hard braking, where the wing shifts to its steepest angle in just 0.3 seconds, acting as an aerodynamic air brake. By instantly dumping massive downforce onto the rear axle, it eliminates body twitch and delivers perfect stability under heavy deceleration. This wind deflector rising behind the seats completely eliminates the cabin turbulence caused by backdraft airflow. By bending the air upward over the seats, it creates an isolated pocket of calm air, keeping your hair from blowing at high speeds while letting the pure engine note flood the cabin. The complex mechanical arms that fold the Amalfi Spider's roof within seconds are not made of ordinary steel. To prevent the roof mechanism from raising the car's center of gravity, engineers crafted these moving joints entirely from aerospace-grade, lightweight magnesium and titanium alloys. Furthermore, this roof can operate on the move at speeds up to 45 kilometers per hour. To prevent heavy gusts of rear wind from damaging the mechanism during operation, special pressure sensors are integrated into the hydraulic arms, instantly locking the system within milliseconds if danger is detected. Delivering massive power to the rear wheels, Ferrari's twin-turbo V8 launches the Amalfi Spider from 0 to 100 in under 3 seconds. But the real performance shines at high speeds. Thanks to the smooth lines and ground effect, The car doesn't fight the wind as it accelerates. Instead, every single horsepower is converted directly into pure acceleration and flawless cornering grip. This is what makes the Ferrari Amalfi Spider truly unique, not just its raw horsepower, but the flawless engineering that treats airflow not as an obstacle, but as a medium for performance. Which of these aerodynamic details impressed you the most? Let me know in the comments below. Don't forget to like, subscribe, and I'll see you in the next engineering breakdown.